Just an update on the code. I've done a little bit of work on it, and an update on the hardware. So this is a 2-colour OLED, and there's a little bit of a gap between the yellow and the blue, unfortunately. I thought it was just an overlay over the top, so you had sort of blue filter, yellow filter, but it looks like there are actually 2 areas of OLED pixels. There's a slight gap between the two, so they misalign a little bit. So I've also... I'm now running the calculator off the power supply on the board, so that's just dropping the 3.3 with a diode, which should be okay. And that means I don't have to worry about batteries. Obviously I take the batteries out of the calculator. The VCC for the calculator comes out on the connector, so you can do that. I don't know if that was intended. I don't think there was actually an AC adapter for this calculator, but obviously the capability was there. So at the moment I'm displaying a status display on the OLED, but I can change that to a different display. And the way you do that at the moment is to send a particular value with a particular exponent. So if I send 1.1 times 10 to the 40 out just as one display, you can see that the display is updated there. And if I send 1.3, so it's the second digit that is the actual number of the page that I'm displaying. So that's now displaying the contents of 8 memories. Now they're not memories in the calculator, they're the memories that are sent from the calculator. So if I've only sent 1.3 times 10 to the 40, so you can see the top line was 1.3 times 10 to the 40. And when you send the X register, that goes in the position for the F register, or F memory in the calculator. But if I send everything now with an inverse save XE, it takes a little bit longer, but there you go. So these are the contents of, I think it's 9 memories, isn't it? 8 or 9 memories. There's 2 in yellow, obviously, with that gap between the yellow and the blue, and then there's another 6 down the bottom, so it is 8. So which memories are displayed you could change. I haven't done that, they're fixed at the moment. But so if I put 1, 2, 3 in memory 5 and then do the save again, you can see that memory 5 changed to 1.3 times 10 to the 0. So it's a sort of fixed point, fixed format display here. It's not the same as the calculator display. They do leading zero suppression and things like that. But here the decimal point's always after the first digit, like scientific notation. And the reason for that is that this is the format, more or less, that's sent from the calculator. So that's what the calculator sees. Now if I do 1.2 times 10 to the 40 and send that, now that's more interesting, it's gone blank. Now I do have a program stored, so if I set up that program as 5.10 times 10 to the 47, if I send that, that will cause the blue pill to load file number 510. So if I put that back to, is that going to do it? 40, let's put it back to the status display. So there you go. So file number P510.dat has been loaded. So if I then load that in mode 3, I think we need to clear everything in mode 3 first. So that should get loaded. Now it's file 0 because I've changed the status display. We have to go back to mode 1, 5.10 times 10 to the 47. There we go, we should see it change. So 274 bytes have been loaded from P510. So if I go to mode 3 now and now load that program from SD card, we should see an FP510 appear, like that, and now it's loaded. If we go back to mode 2, there's a P0. So I've set P0 up to do some stuff, which will be obvious in a minute. So if I run that, but I put a 1.2 times 10 to the 40 in the display, So that's now gone blank, but the reason for that will become clear. So a pixel's appeared. So this is now drawing from the calculator a graph on the OLED display in graphics mode. So the 502 is now a very slow, very slow graphing calculator. Obviously you need the PCB attached to it. So what it's doing is it's sending values out with the special exponent, and that value has encoded in it the X and Y coordinates of the pixel that you want to set. So that is pretty slow, but if you wanted to deal with sine waves, you could change the code and have a special value that is sent out which encodes the parameters of a sine wave, and you could do this entire sine wave in the time it takes to plot one of these pixels. So it is plotting a sine wave here. So the program is just taking a value from 0 to 127, which is the x-axis, working out what the y value is for a sine wave, and I've scaled it appropriately to fit on the screen, and then sending that value with an inverse save inverse xe. So it's just sending one value over, and that's fairly quick. It's quicker than the FA1 because the header has been trimmed down to the absolute minimum in the code. So for loading and saving, it is faster than loading or saving from tape. So I'll leave that. It will take a while to complete. I'll speed this bit up. So there we go, it's finished. Zero's come up on the display. If we have a look in one of the memories, this is the value that is sent to the little adapter. So the 1 is just a placeholder, and then you've got 001, which means X of 001, and then Y is the next 3 digits, 033. The 874 is just left over from the calculation. So that's saying plot a pixel at XY of 133, which is the last pixel on the display. And the times 10 to the 50 is used to encode which of the values this is. So in this case it's the plot value, if you like, the 50. You could encode that in the leading 2 digits or something like that if you wanted. But at the moment, let's put, so the times 10 to the 40 is setting up the page to display. So that's gone back to the status display from the graphics display. The graphics display is now wiped out, so that's gone. That 2 or 3 minutes of effort has gone. So if you want to load a program, it's, for instance, 1.23 times 10 to the 47. You do that, and that loads a program. If you want to load a memory file, it's 1.23 times 10 to the 48. Oops. And that's now loaded M123.dat, which is 194 bytes rather than the 200 odd for a program. So SD card read and write works, and I can plot graphs very slowly. And you've also got that rather interesting memory display, so we can have a look at the memories that we used for the plotting. So actually they're off the display. Oh no, they're not. So it's memory 8, which has got something in it, and it was memory 7. So 7 and 8 were the memories that we used for the calculation. So I've actually got to save all the memories to get those values out. So there we go. So 8 has got the value we were looking at just now, and 7 has got it's actually got 0 in it, which is times 10 to the minus 100. That's just the decoding, and that's the X coordinate in memory 7, and the value that's sent to the gadget in memory 8. So yeah, it's working, it's doing things. It's quite nice. I think a 3D printed sort of thing for the PCB to fit in that fits on the runners would be nice, because it's a bit wobbly, it's not particularly sturdy, and that would be useful. And maybe shrink it down as well, have a cut down version, maybe without a display. I'm not sure about that, just SD card, just to get storage would be quite useful. Although the display's nice, you get the graphing and you get the memory display there, which is quite nice. But yeah, I'll have a think about that.